Hello, all. We are here today talking about rewriting in log form. So far, we've talked about a lot of different things to do with exponential equations and exponential functions. And today we're going to dive into some logarithms. Logs are the inverses of exponents, so the two kind of go hand in hand. And today we're going to explore the comparisons between the two. As always, this is brought to you by Condolenzo Inc. We're here to help with all of your math needs. Our goals for today are to be able to rewrite an exponential expression as a log expression and to rewrite a log expression as an exponential expression. So we're really going to focus on comparing the two of them, how their pieces work together, and then rearranging those to go from one to the other. Here we have an example of an exponential function, and we've named each of these parts just to kind of help us when we're rearranging. So we have a base, which is b, that's a number. We have an exponent, which will be our x, our variable, and then we have that equal to an answer. As a general rule, that will be some sort of number when we're solving. It's equal to y when we're graphing, which we've already kind of looked at a little bit. The inverse of an exponential function is a logarithmic function. Notice it has some of the same pieces. We're adding in a log, but they're in different places. So your base becomes the base of your log. Your answer moves next to the log and your exponent actually becomes what it's equal to. So notice these are all the same pieces as before. Oops. We have the exponent, we have the answer, we have the base. They've just moved around a little bit. So that's what we're going to explore today is rewriting those and moving the different pieces to different places. Let's try a couple. So we are going to rearrange these logs to rewrite them as exponential functions. So let's start with what is our base? Our base is 8. If it helps, think about 8 is in the basement of the log. That's the base of my exponential function. My exponent, remember, is 2 because that moves around, and then my answer is 64. Now, an easy way to check this, guys, it should be right. 8 squared is equal to 64. If you didn't get the pieces in the right spots, you would get an incorrect exponential function. You might get 2 to the 4th is 97. That's not true. That's not a true statement, okay? So when you're rearranging, your expression that you get should be a true expression. Let's try another one here. On this second one, the base is 2. The exponent is 7 this time, and that's equal to your answer, which is 128. Now, if you don't recall that off the top of your head, check real quick on your calculator. Is 2 to the 7th power equal to 128? It should be, and if you hit enter, you will see that it is. Looking at this third one, our base is 4. Our exponent is -1, and it's equal to our answer, which is 1/4. Now, again, sometimes we're not real great with this, so just plug it in your calculator, check and see. Is 4 to the power of, remember you're using your caret button, -1 equal to 1/4? You'll probably get 0.25, which is 1/4. And that is a true statement then. So you know that you've rewritten these correctly. So we're just moving the base, the exponent, and the answer around. Now we're going to go in the other direction. We're going to take an exponential and we're going to rewrite it as a log. So let's start with log. Our base, remember, goes with the log. So this is a base 10. Next comes our answer, which is 1,000, and that's equal to our exponent, which is 3. We just rewrote this exponential in logarithmic form. We put our base next to the log, then comes our answer, and it's equal to our exponent. Let's try another one. Over here we have log. Our base is 9. Our answer is 3, and that's equal to our exponent, which is 1/2. Now, please notice as I'm writing this, I'm writing things proportionately. So the base is always smaller because it's the subscript or the base of the log. The 3 is the answer. It's not an exponent of the 9. It's log base 9, so that's why the 9 is little, of 3, and then is equal to, notice the exponent is no longer a little number. It's just written regularly like the 3 is, okay? Let's try this third one. Log, and then our base is 5. Our answer is 1/25th, and that's equal to our exponent, of -2. We just rewrote all of these into logarithmic form. Very nicely done. I hope that you're understanding this. This isn't a terribly difficult concept, but because logs are so new, it's really important that we know how to rewrite back and forth from log form to exponential form, from exponential form to log form. We're going to be using this skill a lot as we move forward. So we want to make sure that you're really, really solid on it. Now, another thing that you need to know is that when bases of logs and exponents are the same, they cancel each other out. So, for example, if I look at this log here, my base is 5. And if I look at this exponential, my base is 5. The log base 5 and the base of 5 cancel each other out, which leaves me with 7. We're going to be using this to help us solve as well. So, it's really important that we know what it looks like, okay? Look at this next one. This is an exponential function. The base is 9. And then in the exponent, I have a log with a base of 9. Those cancel each other out, and I'm left with just the 14. Now, eventually, I'm going to have variables in here, like on this next one, which is going to help me solve. So I have a log base 7 and an exponent base 7. Those are going to cancel, and I'm left with x plus 3. Now, can you see if I had maybe made this equal to 12? Now I could solve, right? And I could figure out that x would be equal to 9. That's what we're eventually going to be doing, not right now. Right now, we just need to know that when the base of a log and the base of an exponent are the same, they will cancel each other out if they're together in the same expression. Okay, we're going to use that again eventually to help us solve. So hopefully after this lesson, you are able to identify the parts of an exponential as well as identify the parts of a logarithm. You need to know what the base is, you need to know what the exponent is, you need to know what the answer is for both of them. You also are hopefully able to rearrange a log and rearrange an exponential. We want to go from log form to exponential form. We want to be able to go from exponential form to log form. It's very important that we're able to do this skill so that we can use that to then eventually help us solve some equations. Please know that we are always here to help you. Both Ms. Khan and Ms. Alonso are willing to answer any math questions that you might have, so please let us know how we can help and what we can do to make sure that you really understand logs and exponentials. Take care and have a wonderful, wonderful time doing your math.